This is a video looking at circuit laws as part of the Year 11 Physics Electricity and Magnetism module. So there's two really important circuit laws that we learn about in Year 11 Physics, and they've got a name. They're called Kirchhoff's laws. Named in honor of the German physicist Gustav Kirchhoff, who made a lot of insights, a lot of important contributions to electrical circuits, among other things. And Kirchhoff's laws are basically tied with conservation principles. So fundamental principles in physics. So the first law of Kirchhoff is called Kirchhoff's voltage law, also known as the law of conservation of energy. So let's see how this works. Let me draw a simple circuit. I'll draw a battery. And I'll draw two resistors connected in series. Let's call that resistor 1, resistor 2. Current, let's have it flow clockwise by convention. Goes from positive to negative. So around the loop, we find that the change in the total voltage, which is the same thing as saying the sum of all voltages across the loop, the circuit, is simply the voltage of the battery minus the voltage of the first resistor minus the voltage of the second resistor. And that must equal zero. The change, in other words, in the voltage must be zero, in the energy, in other words. Okay, that means it's constant. The voltage is constant across the circuit. So energy from a voltage source is conserved. That's what that says, this statement here. Let's see how this works. So suppose we have a 12-volt battery in this circuit, and the voltage of the first resistor is 3 volts, and the voltage of the second resistor is unknown. How do we work it out? Well, we use Kirchhoff's voltage law. So the sum of all voltages is just the voltage of the battery minus the voltage of resistor 1 minus the voltage of resistor 2. Let's plug in our numbers. 12 minus 3 volts, 12 volts minus 3 volts minus R2. Now this has to equal 0 by definition. If you rearrange this mathematically, you'll find that R2, the voltage of the second resistor, is just 9 volts, okay? 12 volts minus 3 volts. That's Kirchhoff's voltage law. Kirchhoff has another law called Kirchhoff's current law, also known as conservation of charge. Let's see how this works. So I'll draw a circuit once again. Here's a battery. Suppose I have two resistors connected in parallel. Okay, suppose I've got points here A, B, C. Now, this region here is called a junction. Okay, junctions where there's something that's splitting into two or more things. So suppose you're at a road, let's say, driving along, come across a junction. A junction is like a place where the road splits into two or more different sections, right? That's a junction. Similarly, in this case, if current's traveling along, let's say, to the right like this, and it comes to this point here, just before B, well, it has to split into two or more directions, because that's what a junction is, right? It splits the current here. And since charge doesn't accumulate, doesn't build up in junctions, or it's not used up, you've got the same amount of current flowing through in this direction and this direction. Okay? In other words, the sum of currents flowing around the circuit, the loop, is 0. Okay? In other words, the current going through point A minus current through point B minus current through point C has to be 0. Let's do an example. Suppose we have current at point A equaling 2 amps, and there's 3 times as much current passing through B, point B, as C. Calculate currents at B and C. So let's do this. So let's write this in terms of symbols and numbers. So the current flowing through point A is 2 amps as we're given. And we know that the current flowing through point B is 3 times the current flowing through point C. So let's use Kirchhoff's current law. Sum of all currents is IA minus IB minus IC, which is 0. So IA is basically 3IC minus IC, okay, because I took these two guys over. Now 3IC plus IC, mathematically, is just 4IC, right? Think of it as like 3x plus x. So therefore, the current through C is just current through A divided by current through A is just 2 divided by 4, so we get half an amp flowing through point C. Okay, and similarly for the current flowing through point B, so we can use this expression once again. So the current IA minus IB minus IC 0. Okay, we know that current through point A is 2 amps minus IB minus, I should say, there's an even simpler way of doing this. Current through point B is just 3 times the current through point C. And we know what IC is, so we go 3 times half, and that's basically 1.5 amps. That's how we use Kirchhoff's current law.